Okay, let's continue. We'll study absolute values. So let A, B be reals. We can ask what is the distance between A and B? So note that the distance between A and B is B minus A if A is less than or equal to B, and A minus B if A is greater than B, right? So if we have this situation where A is less than or equal to B, this is B minus A is the distance. And if we have a situation where A is greater than B, then A minus B is the distance. So the distance between A and B is B minus A if A is less than or equal to B, and A minus B if A is greater than B. The same thing we can write it as. So hence, distance between A and B is B minus A if B minus A is greater than or equal to 0, and minus of B minus A if B minus A is less than 0. We can write it like this. We get this. So writing this suggests that, so we have B minus A if B minus A is greater than or equal to 0, and minus B minus A if B minus A is less than 0, right? So this suggests defining. So we can define modulus of x to be, the expression mod x will be x if x is greater than or equal to 0, and minus x if x is less than 0. So this suggests defining this. Then distance between A and B is simply, so distance between A and B is just mod B minus A. It's B minus A if B minus A is greater than or equal to 0, and minus B minus A if B minus A is less than 0. So it's just mod B minus A. So then distance of A and distance between A and B is just mod B minus A. So the distance function is, you take the difference and apply the modulus function. The modulus function is mod x is x if x is greater than or equal to 0, and minus x is if x is less than 0. So this is one definition of mod x. So this is one definition of mod x. We can ask, like, can we define mod x in an alternate way? So let's see, let x be a real. So note that x square would be always greater than or equal to 0, and square root of x square is, this is x if x is greater than or equal to 0. If x is greater than or equal to 0, x itself is the unique positive real such that x square is, it squares to x square, and otherwise it is minus x. So hence we can define, hence we see that mod x is just square root of x square, right? So we have two definitions of mod x. One is this casework definition. Mod x is x if x is greater than or equal to 0, and minus x if x is less than 0. And the same thing you can also write it as square root of mod x is square root of x square. Okay, so I think that's all for about modulus. We'll see an example. So simple example, find the values of x such that mod x plus 5 is 2. So note that, so whenever you have mod something, it's defined using casework, so it's natural to consider casework. So note that the statement mod x plus 5 equals 2 and x plus 5 is greater than or equal to 0. This statement can be simplified as x plus 5 equals 2 and x plus 5 is greater than or equal to, so I'll write it as x is greater than or equal to minus 5. So this is same as x equals minus 3 and x greater than or equal to minus 5. So this is same as saying x equals minus 3. So this specific statement mod x plus 5 equals 2 and x plus 5 is greater than or equal to 0, saying that is same as saying x equals minus 3. So again note that, now we'll take another statement, mod x plus 5 equals 2 and initially we took x plus 5 greater than or equal to 0. Now we'll take x plus 5, the other possibility, x plus 5 is less than 0. So this statement is same as saying minus of x plus 5 is 2. So x plus 5 is negative, so mod x plus 5 will be minus of x plus 5. Minus of x plus 5 is 2 and x plus 5 is less than 0. So this is same as saying x equals minus 7 and x less than minus 5. So this is same as saying x equals minus 7. Hence the original constraint and like the original equation we are interested in, mod x plus 5 equals 2, this is same as saying mod x plus 5 equals 2 is same as saying, so since x is real, it's same as saying mod x plus 5 equals 2 and x plus 5 is greater than or equal to 0, or mod x plus 5 equals 2 and the input mod x plus 5 is less than 0. So we saw that mod x plus 5 equals 2 and x plus 5 greater than or equal to 0 is same as saying that is same as saying x equals minus 3, and saying the mod x plus 5 equals 2 and x plus 5 is less than 0 is same as saying x equals minus 7. Sorry, or this is or. So you get this x equals minus 3 or x equals minus 7. Hence you get that saying mod x plus 5 equals 2 is same as saying mod x equals minus 3 or x equals minus 7. Hence the solutions of mod x plus 5 equals 2 are x equals minus 3 and x equals minus 7. These are the only possible solutions of this equation. So right, so that's all for this part. See you in the next part.